Welcome everyone. So today we are going to explore Retrieval-Augmented Generation, RAG, which is a powerful AI technique that makes language models smarter, more accurate and up-to-date. So before we dive into the details, let's start with a simple question. Have you ever asked an AI a question and it gave you an incorrect or outdated answer? That happens because traditional AI models rely only on what they were trained on, and they can't update their knowledge without retraining. RAG changes that. It allows AI to retrieve new information before generating a response, making it far more accurate and reliable. So traditional AI models like ChatGPT, like Gemini, are powerful, but they have limitations. They don't know about new events, specific knowledge, unless retrained. They sometimes hallucinate, meaning they generate false information. They can't access external knowledge sources, specific knowledge sources, our knowledge sources in real time. But with RAG, AI can retrieve the latest facts before answering, reducing errors and improving reliability. So RAG makes AI more like a knowledgeable assistant rather than a text generator. So in this session, we will see specifically how RAG works behind the scenes, why it is better than traditional AI models, and how we can build RAG-powered AI systems using tools like LangChain and LangFlow. By the end, you will understand how RAG is transforming AI into a real-time, knowledge-driven assistant. So what is an LLM? Let's start with the basics. An LLM is an advanced AI system that has been trained on a massive amount of textbooks, on a massive amount of articles or websites and more. Some well-known LLMs are ChatGPT, Gemini, and Llama from Meta. These models are used for tasks like answering questions, like summarizing text, like writing content, and even do coding. So think of it as a supercharged autocomplete. When you type a question, it predicts the most likely response based on everything it has learned. So an LLM is an advanced AI system that has been trained on a massive amount of textbooks, of articles, of websites, of everything that is online. And after being trained, then it can generate content based on the knowledge that it has acquired. But we have specific challenges with traditional LLMs. Standard LLMs like ChatGPT and Gemini have two key weaknesses. One is outdated knowledge. LLMs can only generate answers based on their pre-trained data. If the model was trained months or years ago, it will not know about recent events, about scientific discoveries, about policy changes, or anything specific that we know and we want our LLM also to know. And hallucinations. So LLMs sometimes make up information when they do not know the answer. This happens because they try to predict the most likely response based on patterns rather than real facts. For example, if you ask a standard LLM what are the latest AI regulations in Europe, it may provide incomplete or outdated information because it was trained before those regulations were finalized. Now that we understand what an LLM is, let's introduce Retrieval-Augmented Generation, RAG, which is a powerful technique that makes AI smarter and more reliable. So what exactly is RAG? Simply put, RAG is a method that combines retrieval, which means searching for relevant information, with generation, which means creating responses using an LLM. So instead of only relying on what it learned during training, a RAG-powered AI can retrieve fresh or relevant knowledge before generating an answer. So, Retrieval-Augmented Generation is a technique that combines information search with text generation from a large language model, from an LLM. RAG is a technique that improves AI models by combining two things. The first is retrieval, so instead of only relying on training data, the AI searches external sources, for example databases, or documents, our documents, or information through APIs from other websites to find the most relevant, the most up-to-date information. The first is retrieval, the second is generation. So once it has the correct information, the AI generates a response using that data, ensuring accuracy and relevance. So this makes RAG models smarter, more reliable, more dynamic, able to answer questions based on specific knowledge, just like a student who checks their textbook before answering. Why is this important? How RAG solves these problems? RAG improves AI models by allowing them to retrieve relevant real-time information before answering. And this has three major benefits. The first is that it improves accuracy, pulls information from reliable sources before responding. Instead of relying only on memory, RAG searches for up-to-date facts from external sources, ensuring the information is correct. It limits false information, reduces hallucinations. So the model is based on up-to-date information, not only on its training data. Because RAG pulls answers from reliable sources, it prevents the AI from guessing or fabricating facts. And finally, increases utility and adaptability, allows AI systems to have dynamic knowledge by updating their answers with new information. So RAG allows AI to be dynamic and responsive, meaning it can answer questions about new trends, emerging technologies, and real-time data without needing to be retrained. Now a simple analogy, student versus RAG-powered AI. Imagine a student taking an exam. A standard LLM is like a student who tries to answer based on memory alone, which can lead to mistakes if they don't remember everything correctly. A RAG-powered AI is like a student who checks a textbook or online sources before answering, ensuring their response is accurate and well-informed. So just like how a student can access to the right materials gives better answers, exactly in the same way an AI using RAG is much more reliable than one relying only on pre-learned knowledge. Now, let's see an example between standard LLM versus RAG-enhanced AI. Let's compare how a traditional LLM and a RAG-powered LLM handle the same question. So user asks what are the top advancements in AI for 2025. And here we can see the feature in standard LLM and RAG-enhanced LLM. So response source. The response is based on past training data in standard LLMs, while in RAG-enhanced LLMs retrieves live research papers and news articles. Regarding accuracy, the standard LLM may provide outdated information, while RAG-enhanced LLMs provide up-to-date with the latest research. Regarding reliability, in standard LLMs, there is the risk of hallucinations, while in RAG-enhanced LLMs, it is based on real sources. And finally, regarding flexibility, standard LLMs cannot learn new things without retraining, while RAG-enhanced LLMs adapt to new data instantly. So because of these benefits, RAG is widely used in fields where information needs to be accurate, for example, legal or financial AI assistance, up to date, like healthcare and scientific research, dynamic, like customer support chatbots, retrieving specific product documentation, or context-aware, so AI search engines that summarize real-time information. So with RAG, AI moves beyond static knowledge, and this makes AI even more powerful for real-world applications. RAG is important because it allows AI to provide accurate, up-to-date, and trustworthy responses. It doesn't just rely on what it remembers, but can also search, retrieve, and reason with new information in real time. But how does it work? How does RAG actually work? Here is the process step by step. Initially, the user enters a question, just like asking ChatGPT or a search engine. The system searches for relevant information. It looks in specific sources, in trusted sources like a database, like specific documents or APIs. The language model generates a response. Instead of guessing, it uses the retrieved information to answer. The final answer is returned, more accurate, more up-to-date, more reliable. So, how RAG works in practice? Now that we know what RAG is and why it is important, let's break down how it actually works behind the scenes. So, RAG is a combination of two key processes. The first is retrieval, which means that the system searches for the most relevant information from a database or from a document repository. And the second is generation. The AI creates a response based on the retrieved information, ensuring that the answer is accurate and up to date. So, step one, user asks a question. A user types a question, types a query into the AI system. For example, what are the latest trends in AI ethics? A standard LLM would generate an answer based only on its pre-trained knowledge, which might be outdated, but a RAG system works differently. So this initial prompt is converted to numeric vectors. The query is converted to arithmetic vector representation through an embeddings model. For example, OpenAI, text embedding, 3Large, or other embedding models that we will see later. Then we have data retrieval. The system searches for similar information in a database, in a vector database, such as AstraDB. Then the language model, the large language model, the LLM, like GPT-4, like Llama, like Gemini, creates a response, takes the recovered data and generates a rich response. And finally, the user receives a documented answer based on retrieved data. So here, in this process, we have specific technologies used. We have vector databases like AstraDB, like Pinecone, like FICE, like ChromaDB. We have LLMs, large language models, like OpenAI GPT-4, like Llama, like Claude, like DeepSeek. And finally, we have the embeddings models, which is the way of converting the strings, the queries to numeric vectors. So converting them to arithmetic vector representations through these embedding models from OpenAI, from Cohere, from Hugging Face. Why this process is better than a standard LLM? Because we do not have fixed pre-trained data, but we have real-time external data. Regarding the updates in traditional LLMs, we cannot update knowledge without retraining, while in RAG-enhanced AI, we have dynamically retrieving new data. Regarding accuracy, it might be outdated for traditional LLMs, while in RAG-enhanced AI is always based on latest information or specific knowledge. And finally, the hallucination risk is high in traditional LLMs, while is much lower because it relies on real sources in RAG-enhanced AI.